Right, so the topic is called power and exponent. We'll just quickly go over what's inside. Each year, I think since grade 8, right, you start to learn some exponent rules, right? Get to know what's exponent, what's a base. And then grade 9, grade 10, you learn a few more rules each year. So in grade 11, we add another rule for exponent, okay? So the first page here is just reviewing all the rules you've learned so far up to grade 10. So you learn about how to deal with same base, right? Same exponents, and what happens when the exponent is 0, right? And then negative exponents, right? What does it mean when you have an exponent that's a negative number? So the next 2 pages is just reviewing some of the exercise that you've done before, okay? So first part is review, and then part B, page 13, is the new rule that we will introduce this year. So what happens if the exponent is a rational number, is a fraction, right? It could be decimal, right? But decimal can be changed to fraction. So overall, you just know how to deal with fractions, okay? So as you can see, the fraction exponent has to do with the square root or cube root, right? Radical, we call that a radical sign, okay? So that's a new rule we'll be learning. And then after that, that's all, okay? So it's pretty straightforward topic. You just learn one extra rule. So today I wish to complete all the review, okay? Maybe, right, start a little bit of the new rule. So let's look at the first part, right? First section. When you have the same base, I'm assuming everyone knows what's the base, right? If I have 5 cubed, this is the base. Okay, and then this is the exponent. Okay, everyone should remember that. So the first rule is saying that if you are multiplying with the same base, the exponents should be added together, right? For multiplying, if it's dividing, it should be subtracting exponents. If it's power, right, a to the nth power and then to the nth power, if the exponent are next to each other, then you would multiply. Okay, so we're gonna review these rules and try to simplify, okay? Simplify the expression on the right side. So for example, on the right, in the numerator, question A, okay? You multiply together, so the exponents you add it together. You get 2 to the 15. And then for denominator, you have 4 and 2, right? To the 4 to the 2. Then you will be using the third rule. So it'll be 2 to the 8. Okay, so you simplify numerator and denominator first. And then, which rule should we use now, Colin?
The dividing thing.
Yeah, so what would you do?
So 2 to the 7.
Yeah, so you will subtract the 2 exponent, you get 7, okay? You don't need to find out what 2 to the 7 is. You just simplify it, okay? So that's your answer. So at the end, right, all the same base, they combine together into one base, okay? So I'll let you try question B. And then at the end, you should get some x to the something, y to the something. The x and y, they are the base. All right, so please raise your hand if you have an answer for B. Are we done? Almost. Does anyone have questions about B? Is it harder than you thought? We only have 3 people finished. Okay, Eric, are you stuck?
No, I finished it.
Okay, you gotta raise your hand. How about you, Colin?
I'm almost.
Okay. Okay, Eric, what's your answer look like?
I have x 14 times y.
14y. Okay. How about Nathan?
I had the same as him.
Same. Okay. Colin, any trouble?
I got that too after.
Yeah. Okay. So yeah, these ones, right? Very straightforward. You either add or subtract or multiply. Okay. So for the top, 5 and 3 will multiply, right? Using rule number 3, extra 15 times. I use a dot. Okay. X y squared over x squared y. And then I'm gonna multiply the top, right? 15, extra 15 times x. X has an invisible 1. Same with the y at the bottom, has an invisible 1, okay? If you don't see it, that means it has an exponent of 1. So the top, you will add a 15 and 1, so x to the 16. In the denominator, x squared y to the 1. After that, they are dividing, right? So you will subtract the 16 and the 2, and 2 and the 1 you subtract. So you get the final result, okay? So just add and subtract and multiply, right? Shouldn't be too much a problem. Next part is what happens when the exponents are the same. So rule number 4, right? Usually you will see a bracket, okay? That's giving you a hint that you to use. So, okay. So you have one bracket here, right? So outside, the inside you have 2 base. Okay, one is the A, one is the B. So the exponent on the outside will go in and share with each of the base. And remember that once you separate them, you get 2 little brackets. Okay, so everything in the bracket will repeat and will carry the same exponent. So for example, question A, I'll let you guys try A first, okay, without explaining. A and yeah, question A. Okay. So once you got answer for A, please raise your hand. We'll just check A. Okay, Yosher, what's your answer for A?
4x squared.
Okay, Colin, how about you?
Same thing.
Same thing. Okay. Now this one, the inside you have -2 as one of the base and x as the other. Okay. So the square will affect both of them. Okay. So if you are showing detailed step, right? It will be -2 squared and x squared. So -2, because it carries a bracket, it will be negative times negative, makes it positive, okay? X squared. So that's your answer. Okay, so I'll let you finish B and C now, right? B and C has more things on the inside. So again, please raise your hand when you finish B and C. Okay, Aaron, what's your answer for B?
8x to the power of 6.
Yep, very good. Okay, so it'll be 2 to the 3 times x squared to the 3. Okay, you can put the brackets around 2 or not, it doesn't matter because it doesn't have negative. Okay, so compare B and question A and question B. The difference is the 2, one has a negative sign, the other one doesn't have negative sign. If there's a negative sign, it's better to, you have to carry a bracket, okay? Because you want to include the negative as part of the base. Okay, question C. Eric and Nathan, are you guys done?
Yeah.
Please raise your hand if you're finished. Okay, Brendan, what's your answer for C?
25x to the power of 4, and then 4y squared z squared.
Yeah, 4y squared z squared. Okay, so you just here in the exponent to 1, 2, 3, 4, 5, right? 5 things. And remember the -5 needs to carry a bracket, okay? So -5 times -5 give you positive 25. Okay, brackets is important. I keep saying that, right? So you can see on the next part, rule number 6 is saying if the base, if the exponent is 0, then the whole answer becomes 1. Okay, and if you look at the example on the right side, question A has brackets, question B has no brackets, but everything else is the same. Okay, so think about how the answer will be different, or are they the same, right? But first, let's just quickly go over why exponent of 0 can become a 1. But before I say that, does anyone know why? Why the exponent is 0 will make the whole thing 1? Eric, do you know?
I'm not sure.
Okay, you ever wonder why?
Yeah, sometimes.
Yes, okay. It's a very weird rule, right? How about you, Sarah? Do you know why?
No.
No, you're sure?
No.
No, okay, okay. Nobody ever want to ask why, no? They just say it there, huh? Because teachers say so. Okay, you can think of exponent of 0 as to make it 0, right? We can use something we agreed before, okay? Rule number 2. When you are dividing, then you can turn it into subtracting, right? Subtracting the exponents. So to get a 0, that means you have two numbers that are the same subtract each other. Does that make sense? So let's say we have 3 to the 0. Then that's the same as any number subtract itself, right? So let's say, Nathan, can you pick a number? Your favorite number.
25.
Okay, so it will be the same as 25 minus 25. Right? 3 to the 0 is the same as 3 to the 25 minus 25, right? 25 minus 25 is same as 0, right? So box that, the 0 is the same as this. Okay, so now think about the rule number 2 backwards. If you are subtracting, then it's the same as dividing same bases, right? So I can write it as dividing. So it'll be the same as 3 to the 25 divided by 3 to the 25. Right? Because when you're dividing with the same base, then the exponents should subtract each other. And because the exponents are the same, that makes the exponent become 0. So if you are dividing two of the same thing, right? Numerator, denominator are the same. What happens when you divide them the same? Eric?
It becomes 1.
Yeah, okay. It's like 5 divided by 5 will be 1. 3 to the 25 divided by 3 to the 25 will be 1. Okay? So you can do that for any number, right? It doesn't matter what the base is, except, okay, there's a number that the base cannot be, okay, which I did not put it here. The base cannot be what number? Anyone? What do you think? The base cannot be what? Has to do with what we learned in the last chapter.
0.
Yes, very good. Okay. If the base is 0, right? Let's say the base is 0. That means the denominator, let me rewrite it, okay? Because if the base is 0, then it looks like this, 0 to 0. Then if I pick any number, 0 to the 25 divided by 0 to the 25, then you have a denominator that becomes 0, which is not allowed, right? You learn that in rational expression. That's a restriction, okay? So this rule will work for any base except 0, okay? As long as the base is not 0, then you are fine, okay? So remember that. All right, so just a quick fun fact for why it becomes 1. Okay, so let's just try question A and B. Okay, the two questions very similar. And how will the brackets make the answers different? Okay, so you can raise your hand once you got the answers for both. Okay, let's see what you guys got. Aaron, what's your answer for A?
-1,
Okay. How about for B?
-2,
Okay. And Eric, how about you?
I have the same -1 and -2.
Okay. And Colin?
The same thing.
Same thing. Okay. Anyone get different things? Everyone got the same? Okay. Everyone's correct. Okay. So this 0 affects this part, right? Affects the 2x. So that makes the base, right? You just need to identify which one is the base for the exponent, okay? For the question A, the base is 2x. So only the 2x changed to 1, okay? The negative is not affected. So negative just stay there. For question B, the base for the 0 is only x because there's no bracket, okay? So the 2 has nothing to do with the exponent. So in fact, what happens was -2 stay there, and then you multiply by 1. So the 0 becomes 1 and -2. All right, last part. This rule you probably learned it in grade 10, is it? Or grade 9? So negative exponents. So negative exponents means it will flip to the other side, okay? It turns into fractions. So here is an easy example to understand why, right? So like 2 to the 3 is like 2 times 2 times 2 will be 8, right? This is something we already know. 2 squared will be 2 times 2 will be 4. So as you move down, you are losing the number of 2. And the way you're losing it is you divide, right? You divide by 2 again as the exponent goes down. Okay? Each time it goes down, that means you divide it by 2. So if you divide by 2 one more time, then that gives you the 1. So you can see it's another way to understand why 2 to the 0 can be 1, right? Because you divide 2 again, right? 2 divided by 2 will give you 1. Now, if I want to continue to go down, right? 0 gets lower, it becomes -1. So that means it will divide by 2 again, right? So that will be 1 over 2. Okay, and then you divide by 2 once again. Go down a little bit more, right? Go downstairs. You get another 2 at the bottom. Okay, so that gives you 1 over 4. Okay, or I like to write it as 1 over 2 squared. Okay, so the -2 is just saying that the denominator has more 2 than the top. Okay, if it's positive, then it's the top has more. Okay, another way to understand this, yeah, this is just observing the pattern. Okay, or you can think of this way. Let's say to the -2. Okay, you can think of two number dividing. Two numbers subtracting give you -2. So let's have two numbers, okay? Please think of two numbers that subtract each other and the result is -2. I want to just use some smaller number, 1 digit, okay? 1 digit numbers. Two numbers subtract each other gives you -2.
2 take away 4.
Yeah, Nathan, what'd you say? What number did you pick, Nathan?
2 take away 4.
Sure, okay. So 2 take away 4 is same as -2. And using the last rule, the subtracting one, right? I can write it as dividing. When you subtract, exponent is same as dividing. Be same as 3 squared, subtract 3 to the 4. Right? So this is telling you that the denominator has more bases than the top. Right? So 3 times 3 on the top, 3 times 3 times 3 times 3, right? Has 2 extra ones. So if you reduce the fractions, right? Reduce the fractions, then you're left with 1/3 squared. So once again, the -2 is just saying the other side has more 2's. Okay, so on the right side, we're gonna go over each of them, okay? First one we already mentioned, okay? So 2 to the -3, what does it become, Colin?
1/8.
Yeah, 1/8, or you can think of the other side has 3 extra 2's, right? 2 to 2 on the other side. So 2 to the 3 is not 6, it's 8, okay? 2 times 2 times 2. Now B, what about question B? Eric, what do you think we should do for B?
You put 2 to the power of -3 on the top because it'd be 3/1/2 to the power of 3.
Oh, okay. So if we ignore the top for now, right? 2 to the -3 is the same as 1/2 to the 3. But then on the top, there should be a 3 up there. Right? So the denominator has a fraction there. So when you divide a fraction like that, you need to multiply the reciprocal. So it'll be 2 to the 3. But it looks very confusing to have a fraction in the denominator, right? So usually I would just go directly to here. Instead of writing out the fraction at the bottom. So if you see a negative, right? Just like before, you see a negative is saying that the other side, it has to go to the other side. The other side means if it was in the numerator, it will go to denominator. If it was denominator, it will go to numerator. It will go to the other side. Okay, and then you change the sign, make it positive. Okay, so for question B, you have 2 to the -3 in the denominator. It will go up, right? Go up to meet with the number 3, and then become multiplying. Okay. Any questions so far? You just switch the side, okay, and then the negative will go. So question C. Do you want to try, Brendan? What do you get?
8/9.
8/9, yeah. Okay, so this one, they both carries a negative, so they will switch side. So 2 to the -3 will go up, 3 to the -2 will go down, okay? We'll go to the other side. You get 2 to the 3 and then 3 squared, okay? Of course, you can simplify, right? 8/9. And last one, question D. Yosher?
27/8.
Okay, so -3 we first can share in. It affects everything on the inside. So you get 2 to the -3 and 3 to the -3. So just now it becomes question C. They swap around. Okay, bottom part go up, the numerator goes down. So Yosher's right, 27/8. So if you're confused of negative exponent, just go back to these 4 examples. These are like the 4 different kinds that could happen, 4 different scenarios. So you can always find answer by looking at these 4, okay? So it's always similar to one of the 4 questions here. Any questions? This is a quick review, right, of everything we've learned so far, all the exponent rules. Okay, are you ready to move on? Can you raise your hand? Okay, so the next page is just practicing, okay? Practicing everything that we just reviewed, okay? So let's look at what it wants you to do. This part is not evaluating, okay? So even though some question they have numbers in there, so it's just simplifying, but please still leave the exponent, okay? So for example, like question 8, right? Of course, this one you just add, right? So if you get 5 to the 9, right? You add an exponent. So you do not need to find out what it equals to, okay? You just leave your answer with positive exponent, okay? Remember keyword here, positive exponent. So if it has negative exponent, you have to find a way to move it to the other side and then leave your final answer positive and simplify as much as possible, okay? Simplify refers to this, something you done here, right? You have many exponents here, you simplify into one, okay? Like question A and B. This page, okay? The next page there. How many questions are here? I think we'll do up to L first, okay? And then we'll go over it, okay? So I'll let you guys complete up to, actually up to O, okay? Up to O has no negative. Okay? And then O. The lettering is a bit weird here, but it's okay. So just do up to where I draw the line. After the line, we have negative exponent. Okay, we'll do that later. So do everything up to O, and then you can raise your hand. Okay, we'll check answer before we move on. Okay, I'm changing the letter at the bottom. Okay, O, P, Q, R, S, T, U. Okay, so you can use whiteout. Okay, change those letters. So I will start asking your answers. I'll give you about 10 minutes. Should be enough. Okay, so I'll go over, start going over at 11:50. And you can raise your hand if you finish earlier, okay? Okay, one more thing to mention is that if you get question like question G, H, I, you start to get variables, right? So for example, like what we did before, like this one. For rule number 4 and 5, if you get a mix of variable and numbers, then the exponent for the number to evaluate. So I'll highlight that, okay? I'll highlight with a yellow. So like 2 to the 3, you need to find the answer for that, okay? When you have mix of variable and numbers. Like -2 squared, you need to find the answer and turn that into 4, okay? -5, you turn that into the 25. The 2, you turn that into 4, okay? And then the exponent for the variable, you simplify them. But if it's just number itself, by itself, like question A, right? Then you just leave it as 2 to the 7. You don't need to find the actual answer, okay? Don't need to find the 2 to the 7, what that equals to. All right, so pay attention to that, okay? So simplifying has a little bit different meaning when it comes to variables. So like G, H, I, right? You have a mix of numbers and variables. Does anyone have questions so far? Eric, what question are you working on?
I'm done.
Okay, please raise your hand. No, we have 4 people finished. 5? Okay. All right, so let's quickly go over that. Okay, Eric, what's your answer for B?
I have 7 to the power of 6.
Yeah. Okay, that one's easy. Yosher, next one.
-5 to the power of 5.
Like that?
No, there's like brackets.
Yes, okay. Remember to put brackets. It has brackets. And Sarah, question D.
4 to the power of
4 to the power of 4. Okay. And question E, Colin.
7 to the power of 4.
Yeah. Okay. Question F, Aaron.
6 to the power of 3.
6 to the
Power of 3.
third. Okay, so we have 6 to 9 divided by 6 to the 6 to get 6 cubed. Okay, question G, Brennan.
25 over y squared.
Yeah, so 5 squared over y squared give you 25 over y squared. And Nathan, H.
Got 9a squared b squared.
Yeah, very good. Okay, so 3 squared a squared b squared simplified to 9. Eric, question I.
I have 16 over 81 times x to the power of 4, and then y to the power of 4.
Yeah, very good. Okay, so the exponent of 4 shares with 4 things. Okay, so you get those ones. Okay, question J, Yosher.
Negative a to the power 10, no brackets.
No brackets, yeah. Okay, so the 4 shared with negative and the a. Okay, this one's a little bit tricky. So negative, 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 right? You get 4 negative makes it a positive. So if you are showing the step, the first negative stays there, it won't go away. But the second negative, it will go away because there are 4 of them, okay? And that turns out in still negative. Okay, question K. Sarah?
X to the power of 2.
Positive or negative?
Positive.
Positive, yeah, okay. So this time the denominator, the negative happens 3 times. So it still remains negative. Okay, so negative divided by negative makes it positive, cancel out. Okay, last one, question, not last one. Question L, Aaron.
Uh, 5 to the power of 4a plus b.
4a plus b. Okay, very good. This time you're adding, right? Because they're multiplying the same base, you will be adding the exponents. A plus 2b plus 3a minus b. Okay. Question M. Colin.
2 to the power of 2x minus 6y.
Okay. M. Question
7 to the power of x plus 2y.
x plus 2y. Okay. So this one, right, because you need to subtract, but the common mistake is forgot to put brackets. So it's 2x plus y subtract x minus y. Okay, so the reason why you get a 2y is because y subtract a negative y makes it plus y. Okay, so it should be 7 to the x plus 2y. Okay, question N. Brennan.
2 to the power of 2x minus 6y.
2x minus 6y, yeah. Okay, so the exponent on the outside will multiply with the exponent on the inside. Okay. And Nathan, last one.
I'm still working on that one, Jason.
And how far are you?
I'm on O right now.
Huh?
I'm on O right now.
Oh, okay. How about we go over all together? Okay. Nathan?
Sure.
Yeah, okay. So for this one, instead of bring in the 2 right now, okay, you can also simplify the inside first. Okay, so ignore the 2 on the outside. Do you know how to do the inside?
Yeah.
Okay, how do you do that?
Like 3 and then A.
Mm-hmm.
A plus 10.
A plus 10. Why is it plus 10?
Plus 2.
Why is it plus 2?
Because isn't it like -4 take away -6?
Yes, very good. Okay, so a plus 2, right? 3 to a plus 2. And then now let's bring back the 2 on the outside. So what are we supposed to do now?
Then you like put the 2 into everything, I guess.
Yep, that's right. So you will get
9.
no, not it. It doesn't affect the 3. Okay.
3a squared plus 4.
No, no. This rule, right? This is exponent, right? A plus 2 is an exponent. Outside is also an exponent. When you have two exponents next to each other, what do you do?
I don't know.
Look at the rules that we review. Which rule tells you about the exponent next to each other? Which one?
Uh, the same exponent one.
No, not the same exponent one. It's in the top 3. Which one?
The same base.
Yeah, which one? Which one of the top 3?
Number 3.
Yeah, number 3, you have exponent, it's like x to the 5, right? And an x to the 3. So that you would, what do you do?
You combine like the exponents together.
Do you add them or multiply them?
You multiply them.
Yeah, okay, so like n times n, right? On the left side, on the
Oh,
right
okay.
side, 5 times 3, okay? When you have
Okay.
exponent next to each other. So over here, same thing, we have
Was it like 2a plus 4?
yeah, okay, so it's not a squared, it'll be 3 to the 2a plus 4. Okay, exponent multiply each other. Okay, last part is the negative. Okay, we'll finish this part and then that's all for today. Okay, so you can, for the next part, you need to turn them into positive exponent. You don't need to evaluate, okay, because there's no variable. You just leave your answer with positive exponent. If they say evaluate, then you find out what it equals to, okay? So finish from P to U, okay? The last six question, then you can raise your hand. Okay, I'll help you out with question P. Okay, so you leave your answer like this. Okay, you don't need to evaluate. If they tell you to evaluate, this is called evaluate. This is simple. This is positive exponent. Okay, if they say please leave your answer in positive exponent, then you stop there. But if they don't say positive exponent, if they only say simplify, then you have to do one more. Okay, it's quite tricky the way they word it in the book. Okay, in the textbook. So if they just say simplified, but does not mention about positive exponent, then you need to continue. Okay, so two different answers depending on what they are asking. Okay, please raise your hand if you finish the last 4. I mean, the last 5. Okay, question Q. Brendan?
1 over 27.
We want to leave a positive exponent.
Oh, sorry. 1 over 3 to the third power.
Yeah. Okay. If it's positive exponent, you stop there. If they say evaluate, then 1 over 27. Okay. And Nathan, how about R?
1 over, is it -3 to the 4?
Yeah, to the 4. Remember, you need to keep brackets. Okay. And if they say simplified or evaluate, right, then it will be 1 over 81. Okay. Next one, question S. Yosher?
1 over 5 to the power 2.
Yeah. Okay, so first simplify into 5 to the -2, and then you turn it into positive. Colin, question T.
-3.
Yeah, -3. This one just goes up, okay? Once it goes up, it's to the 1, so you don't really need to put brackets, but if you do, okay, it's still correct. Okay, Aaron, question U.
2 to the
2 to the,
power 4 divided by 3 to the power of 4.
yeah, okay, so it shares in the negative, 3 to -4, 2 to -4, and they swap place, okay? If they say evaluate, then you write it as 16 over 81, okay? But in this part, we want the answer like this. Okay, that's all for today. We'll do more exponent next time. If you have questions, you can stay after class and enjoy your rest of your spring break. Okay?
Thank you, Jason.
Yeah, you're welcome.
Is there still class next
There's
week?
still class, okay?
Okay.
Yeah. See you next
Okay.
week.
Bye, Jason.
Bye-bye.